In this example, you're being asked to predict the major product or products of each of the following reactions, and if no reaction takes place, you should write no reaction. So just like I said in the previous examples from this question, we're in lecture 14. That's SN2. We haven't looked at other competing reactions yet, so we're not going to look for those competing reactions yet. But in the future, you're not going to be able to just assume, something is SN2. You're going to have to evaluate everything and figure out whether it's SN2 or the other types of reactions, which we're going to talk about. But for the sake of this question, it's most likely going to be SN2 or no reaction. All right, so what we want to do here is we want to evaluate everything the same way we have been. I like to look for the leaving group first, and that helps me identify the substrate. You can look for the nucleophile if you want. Here we go with a species right here with a full negative charge. That is most likely your nucleophile. It's dissolved in ether, so it's an aprotic solvent, perfect for SN2. This must be the substrate, and does it have a good leaving group? Yes, it does. It actually has two good leaving groups. It has iodine and it has chlorine, both of which are good leaving groups. One is better than the other. And if it's better than the other, it's probably going to be faster to react. So I'm also giving you more data here. I'm telling you that you have 1 mole of this methoxide reacting with 1 mole of this substrate. Why am I doing that? Because I want you to show me one product, and I want you to show me the most likely, the expected major product. So you have to think about, all right, well, if there are 2 good leaving groups, where's the reaction going to take place? So let me redraw this species here. We have to remember that that chlorine, it's pulling electron density from this carbon, which means we're getting a partial positive charge on that carbon there, which I'm going to dot in red. This iodine is pulling electron density from this carbon, which I'm dotting in blue, which means we're getting a partial positive charge there. So we have 2 carbons that could potentially be attacked by this nucleophile. Which one is going to get attacked? Well, which one has the better leaving group? So this is where we have to compare the 2 leaving groups. One is going to be iodide, and the other is going to be a chloride. Which one is a better leaving group? We have to ask ourselves, what do leaving groups do? They leave with negative charge. The more stable they are with negative charge, the better leaving group they are. So we have to ask ourselves, which one of these is handling the negative charge better? They both have the same amount of negative charge. They both don't have any resonance, so they're holding that negative charge. But one of them is holding it in a much larger space, and that is the iodine. Remember, iodine is much larger than chlorine. So they both have 1 extra electron, except that iodine has a lot more space for it. It's more polarizable, which means it's going to be the better leaving group here. So what that means is, if we do this reaction with 1 mole of the substrate and 1 mole of the nucleophile, the major product is most likely going to be the result of the methoxide attacking this carbon here, which I'm going to dot in blue, and that is going to kick out the iodide. And therefore, our major product in this case is going to be the methoxide adding to that blue carbon. Let me dot that blue again. Adding to that blue carbon and leaving the chlorine there. And therefore, this is our expected major product of this reaction.